More with the form 0 over 0. Limits with an indeterminate form 0 over 0 can quite often be found using algebraic simplification. There are many more indeterminate forms other than 0 divided by 0. For example, there could be 0 to the 0 power, there could be 1 raised to the infinity power, infinity minus infinity, infinity divided by infinity, 0 times infinity, and infinity to the 0 power. We will discuss these types later on in the course. While the easiest form of simplifying is canceling out common factors, it is not the only one that you will come across. Two other scenarios could arise. One, there could be a complex fraction. In this case, find a common denominator and then try to cancel out a 0, as in example 3 on the next slides. The other scenario would be that there are radicals. Rationalize whichever is necessary, in other words, the numerator or the denominator, by multiplying by the conjugate. Then try to cancel a 0, as in example 4 on the next slides. So let's look at each of these scenarios. Evaluate the limit. The limit of 1 divided by 3 plus h minus 1/3 all over h as h approaches 0. Substitution fails here. When we try to plug in 0, we would get 1/3 minus 1/3, which is 0, divided by 0. And there's nothing to factor and cancel out. So what do we do now? Let's simplify the complex fraction by finding common denominators in the numerator. So we're going to multiply this first fraction by 3 over 3, and the second fraction in the numerator by 3 plus h divided by 3 plus h. And when we do that, we will get 3 minus the quantity 3 plus h over 3 times 3 plus h, all divided by h. And then if we actually distribute this -1 that's in front of the parentheses through to both terms, our numerator will become 3 minus 3 minus h. Well, these first two terms cancel out. So we're left with -h divided by 3 times 3 plus h all over h. And then if we were to multiply both the top and bottom by 1 over h, those h's cancel each other out. That's how they cancel each other out here. And that simplifies to be -1, because we still have this negative here, over 3 times 3 plus h. This shows how the h's cancel each other out. Now we have a form in which we can substitute and evaluate the expression. So we're taking the limit of -1 over 3 times 3 plus h as h approaches 0. So if we substitute 0 in for h, we get -1 divided by 3 times 3 plus 0, or -1/9. Now let's try this example. Evaluate the limit. The limit of the square root of x minus 2 divided by the quantity x minus 4 as x approaches 4. Notice that substitution fails here too when we try to substitute in or plug in 4, because the square root of 4 is 2, and 2 minus 2 is 0, and 4 minus 4 is 0, so we get another 0 divided by 0 form. So when working with radicals, we need to multiply by the radical conjugate first. So the expression that has the radical in it is the square root of x minus 2. Its conjugate is going to be the square root of x plus 2. So we're going to multiply that to both the numerator and denominator. And we're doing that because the difference of squares, remember, gets rid of the middle term that has the radicals in it. So we will just be left with x minus 4 when we simplify the top. And when we multiply the radical by its conjugate, we would get x plus 2 root x minus 2 root x, which cancel out, and then minus 4. So we have an x minus 4 in the numerator, and we have the x minus 4 in the denominator, and those common factors cancel each other out. And now we have a form in which we can substitute and evaluate the limit expression. If we substitute 4 in for x, we would get the square root of 4, which is 2, and then we have 1 over 2 plus 2, which is 1/4. So therefore the limit of the square root of x minus 2 over the quantity x minus 4 as x approaches 4 is 1/4.